Welcome back to the deep dive. Today we're tackling one of the most puzzling gravitational wave signals detected so far, GW190521.
That's a great one to dig into.
Yeah, it started as, a binary black hole merger story, but the details are so strange it's pushed researchers towards some really wild ideas.
Absolutely. When the discovery was announced back in September 2020, it was already groundbreaking. The merger created the first intermediate mass black hole we'd clearly seen, clocking in around 142 times the mass of our sun.
Which is itself a huge discovery.
Huge. But the real kicker was the progenitors, the black holes that merged. One was about 85 solar masses, the other 66.
And that 85 solar mass one lands smack in the middle of the parent stability mass gap.
Right, exactly. That's this theoretical zone, roughly 65 to 135 solar masses, where our models of stellar evolution say black holes shouldn't really form directly from collapsing stars.
So how did it get there?
Well, the thinking was it had to be a product of previous mergers. Smaller black holes colliding and building up over time, hierarchical mergers. That already forced us to rethink some things.
Okay, so that's revolutionary enough, but then there's the signal itself. That's the core puzzle, isn't it?
It is. The signal was incredibly short, like blink and you miss it short, about 1/10 of a second.
The 10th of a second.
Yeah. And crucially, it was missing the usual preamble, the inspiral phase. Normally, you hear this sort of gravitational chirp as the black holes spiral closer and faster.
Like the sound building up to the final crash.
Precisely. But with GW190521, it was almost entirely just the final bang. Very little lead up.
Okay, so that anomaly, that missing inspiral, that's what really opened the floodgates for other ideas.
That's the key. It just didn't fit the standard picture cleanly. And this is where this brand new paper comes in. It's by King Yulan and their collaborators. Just published this month, September 2025.
Right, the title asks, is GW190521 a gravitational wave echo of wormhole remnant from another universe?
I mean, that sounds like something straight out of science fiction.
It does, but they lay out a physical mechanism. The hypothesis is, well, it's pretty out there. They suggest the black holes didn't merge in our universe.
Okay.
They propose the merger happened in a different universe. And what it left behind wasn't just a bigger black hole, but a wormhole remnant.
A wormhole connecting universe.
That's the idea. And the signal we detected, that short burst, they argue it's the post-merger ringdown signal, the bang traveling through the wormhole's throat from that other universe into ours.
So we'd only get the final part of the signal, the echo, which explains why there's no inspiral.
Yeah, exactly. It arrives here as just a short pulse.
Wow. Okay, but how? How can these two radically different scenarios, a weird merger here versus an echo from elsewhere, actually look similar in the data? It's surprising, but when you analyze the signals, they hold up comparably well. We use something called the signal-to-noise ratio, the SNR, to see how clear the signal is against the background noise.
Right.
The standard binary black hole model for GW190521 gets an SNR of about 15.6.
Okay, pretty decent.
Yeah. Now, the wormhole-echo model, it yields an SNR of 14.5.
That's surprisingly close, almost identical, statistically speaking.
It's very close. The difference isn't really significant enough to strongly prefer one over the other based purely on SNR.
So what about other statistical tests? Does anything else help decide?
Well, they did a Bayesian analysis, which sort of weighs the evidence for each model. That analysis slightly favors the standard black hole merger. The log Bayes factor is about minus 2.9.
Which sounds technical, but what does it mean in practice?
It means the standard model is maybe a little more likely based on the data we have, but it's not decisive. A factor like that isn't nearly strong enough to rule out the wormhole-echo idea. It remains, statistically speaking, a viable possibility.
Got it. So both are still on the table, and wasn't there also something about a possible flash of light associated with the original event?
Yes. There's a tentative connection made with a flare observed by the Zwicky Transient Facility, ZTF. The idea was maybe the merger happened near a third supermassive black hole, causing some fireworks.
Did the wormhole paper account for that?
Interestingly, yes. In their analysis, they actually fixed the sky location of their hypothetical wormhole echo source to match the location of that ZTF flare.
Huh. So both models are trying to explain an event coming from the same patch of sky, potentially linked to this other flare.
Exactly. It adds another layer to the whole puzzle.
Okay, so let's just recap where we are. We have GW190521, option 1. It's a binary black hole merger, but a really weird one involving a mass gap object and a strangely short signal, maybe happening in a crowded environment.
Right. An outlier, but within perhaps the bounds of known physics, stretched a bit.
Option 2. It's not a merger in our universe at all, but an echo. A gravitational wave signal from a merger in another universe that formed a wormhole, and the ringdown traveled through to us.
A signal potentially indicating physics beyond the standard model, maybe even hinting at quantum gravity effects or extra dimensions.
That is quite a choice. The implications are pretty staggering.
They really are.
Yeah.
Because if, and it's still a big if, but if the wormhole-echo model turns out to be right, or even just plausible for future events,
Yeah.
it points towards the existence of something truly exotic. The kind of wormhole they model, a traversable Morse thorn wormhole, needs matter with negative energy density to keep its throat open.
Stuff that pushes space-time apart instead of pulling it together. Exotic matter.
Exactly. Stuff we've theorized about but never seen. So the fact that this wormhole model isn't ruled out by the GW190521 data is provocative. It means studying these short-duration gravitational wave events, and there have been others, like GW232123 recently, which look kind of similar, might actually be a way to probe for this exotic matter.
So these weird short signals could be windows into potentially other universes or the fundamental nature of exotic energy.
It's a possibility that this analysis keeps open. It forces us to ask, could these gravitational wave detectors be telling us something profound about connections beyond our own cosmic horizon? It's certainly something to keep in mind as more of these puzzling signals arrive.
A truly mind-bending thought to end on. Thanks for breaking that down for us.
My pleasure. It's fascinating stuff.